All right, hey guys, Mr. Fortin here. I didn't have a ton of time for homework review. I noticed some question marks here. So thank you so much for putting question marks down where you had questions on the homework. In a normal class where we don't do 25 minutes of oral practice like we did in this class, perhaps we'd have some time to go over these in our 35-minute periods. Again, we just did that oral practice just once this chapter, and it's not gonna be every time. So hopefully we have time to go over these in class here. So anyways, the pink group today had a couple questions. They put some question marks down. So let's go over these very quickly. Question 2, plane M and plane N both contain point P. Do the planes have any other points in common? Well, here we got to think about planes. So the planes are obviously intersecting if they share a point in common. But we got to remember, say that this is plane M and this is plane N. Plane M and plane N. Well, how does plane M and plane N intersect? And remember, this is the plane M is really like the plane containing this surface here of or face here of the cube, and plane N is another plane containing this surface here of the cube. How do they converge? Where do they converge? What points would they have in common if I have a plane going this way and a plane going that way? Well, the planes would intersect in looks like a line segment, but remember, planes are infinite surfaces. So two planes intersect in a line. Sure, in a line here. So, and what lines have more than one point in them. Through any 2 points, exactly one line can be drawn. There's more than one point that's on a line. Okay, on a line here. So what's going to justify this answer right here is that the postulate that tells us that two planes intersect in a line. Right, that is the intersection of two planes is going to be a line. There's no other way for two planes to intersect. Their common points are going to be an infinite line, right, going in the one dimension, right, left, right, or some combination. Okay, two planes intersect in line. Second question here, I always get questions about this one. This one's you kind of have to think about, right? I include questions on these because a lot of times standardized test questions, you're like trying to think through it, kind of work through it. So this was a little bit confusing. So I got down this as my example. I don't have a wooden board here, but I have a box, and it's supposed to represent kind of a wooden board. I got a point up here, okay, and I have a point down here, down below, okay, down below. Oops, we can't really see it. Probably should have drawn some more clear points. Okay, so I got 2 points here. So the idea of this is that if we have a board and we want to lay a straight edge on it to see if it's warped at all, okay, so remember, a board would not be warped, right? A wooden board, ideally we'd want to be flat, okay? So we want a wooden board to kind of represent a plane, right? Because a plane is an infinitely long surface, flat surface. So if a board is flat, we can sort of apply the rules that we know about planes to it to say if it really is a plane or not. So here's an example. I have 2 points right here. I'm going to put down this straight edge, and I'm going to lay it on, and I'm going to see if I can connect the 2 points. So here, this point down here, okay, this point down here, I'm going to lay the straight edge. So I'm going to put this here, the straight edge down here, and I'm going to extend it to the other point, okay, to the other point. You guys see what's going on here? Am I actually making contact with that other point right here? Well, no, I'm not actually making contact with that point right there. So here, what the straight edge is supposed to represent in this problem is a line, right? Is a line. If I have to connect these 2 points with a line, okay, with a line, I can't do that super flat, right? I have this space up here, okay? I have this space up here. So the question is, if I have a point here and if I have a point here, this straight edge should theoretically lie flat and connect the two. Because remember, if I have 2 points in a plane, then what would I know about the line connecting or containing those 2 points? It would also have to be what? In the plane itself, okay, in the plane itself. And here, unless I flatten it, unless I work really hard to flatten it, that's not the case, right? That's not the case, okay? So this here is a warped box, right? It's a little bit springy here. It's not a flat surface, because I can't just take a straight edge and touch the 2 points together, because the idea is if I have 2 points on the wooden board, then the line containing those 2 points should also be on the wooden board, because it should be in the plane, right? The plane, the same plane that those 2 points are on here. So my wooden board, or my box in this instance here, does not represent a flat surface, does not represent a plane, and that's the postulate that I would use to justify what I'm doing here, okay? So that is, if I'm able to, if 2 points lie in a plane, then the line containing the 2 points, and I'll resize this here, also lies in that plane. Okay, so we should be able to have any 2 points on a surface, we should be able to lay a straight edge on it, and that line in between the 2 points should also be on that surface because the line containing the 2 points is in that same plane. Okay, so if it's bent at all, the line will, the straight edge will lie off of the actual surface itself, so we would know that the surface isn't flat because between any 2 points, the line containing those 2 points would have to be in the same plane. Okay, a little bit confusing, but I think it's a good one to think about, and also kind of extended the fact that a lot of these geometric principles will actually prop themselves up in actual real life contexts and whatnot. All right, email me if you have any questions. I think that was the only kind of question mark here. There were definitely some tougher problems here. I think this group is still putting up their answers, so they'll get that to that soon. If not, I might check in with them. So some confusing stuff here, so definitely email me if you have one here. Yeah, the ruler posture. I just don't want you to forget about the ruler posture. This is a weird one here. So anyways, between any 2 points, because any 2 points, the ruler postulate tells us that any 2 points, we can assign coordinates to them, and the coordinates are real numbers. So between any 2 points, we can find a point in between those, because in the real number line, there's always space on the real number line in between 2 real numbers. You can always average 2 real numbers together, for instance, and find a midpoint of any segment. So that's what the ruler postulate does kind of tell us, is that it proves the existence. If we have 2 points on a number line, we can always find something in between, because real numbers, there's always in between numbers with real numbers, because real numbers can get smaller and smaller and find more decimals. Anyways, weird one there, and I think you guys had questions on that. And that's about it, right? This was just kind of a brain exploration, and you guys did really well on it. Email if you have any questions. Have a great long weekend. Take care, guys. Bye.